Hi, good morning, everyone. Thank you for the introduction. My name is Omer, from Israel, not from French, as the accent pretty much disclosed me. And I want to start this talk by showing gratitude. First to all the organizers for the amazing work on organizing this conference, so we all have a really good experience, and they definitely deserve some clapping. And second, for choosing me and let me speak here. So it is a big honor, and thank you very much. Hacking like a Fed, front-end developer. It's an acronym I heard recently. So hacking like a Fed. You probably think, some of you think it's weird to have a security session or security talk in a front-end bootcamp or in a front-end development conference. And to explain why we need to have such a talk in not a security conference, but in a developer-focused conference, I want to give you something to think about. We all write code on a daily basis, and we do it a lot, and this is what we do most of the time. And it's good, but it also has downside. Each time we write code, we might introduce very serious security issues, and we might not even be aware to that. Each code that we write could put in risk the organization we work for. And Jim Manico summarized it pretty well, and if you not follow him on Twitter, I really recommend to follow him. He's a really smart guy. He said that all software developers are now security engineers, just because of that. Your code is the security of the organization you work for. And the main problem is that most developers don't know it, don't admit it, or don't know actually what to do about it. And this is something I felt across my career path. I started as a developer. This is me for, I think, 4th grade. I'm not really sure. I always liked computers, and I always worked with them. So I'm a developer, and I always was. And I'm doing it professionally for the last 8 years, give or take. And in the last 4 years, I'm working at Soluto. I started there as a developer, but 3 years ago, I did the shift to application security. And the more and more I learn about security and application security, I understand how insecure the code I write is and how many vulnerabilities I introduced as a developer. So this is something I really feel, and now a lot of my job is helping all the developers at Soluto, and we have some developers here from Soluto. So helping them write more secure code and protecting our customers. Who here heard about Soluto? You might heard about us in the past. Oh, pretty good. So today we are a bit different from what we did in the past. We have around 300 million customers around the world, and we help all these customers to enjoy the most from all the technology we have. And having 300 million customers who put trust in us with our data is a huge responsibility for our developers. And our developers need to think a lot about security and care about security, and this is my job. And there are a lot of tools in the security toolbox that I can use for that. And today I want to show you one specific tool, a tool I like to call Fed's best hacking tool. And this is maybe something you're already using today, GitHub. And I'm going to show you how you can use GitHub to hack the application you write continuously each time you write code. You probably saw something like that in the past. This is a normal pull request on GitHub. I just did some changes, and tests are failing. And the interesting part here is the failing tests are actually security tests, which hack my application, find security issues, and now report it to me. You can look on the PR. There is the link here. I'll put the slide later on my Twitter account, so you can view it. And what I'm going to do today is I'm going to go over the 3 failing tests today, explain each one of the different type of tests, what the tool is, show a nice exploit, and actually teach you the tools so you can start using them right after the talk on your application. And for that, I'm going to use a very special web application called JuiceShop. GeoShop is a vulnerable web application. It's a product of OWASP. OWASP is an open web application security project. It's a non-profit organization. Who here heard about OWASP before? Okay, that's good. So it's a non-profit organization aimed to help developers build more secure code. And GeoShop is one of the projects. It's a vulnerable web application. Don't learn from GeoShop how to write code, because it has many security issues in it. And the idea is to play with GeoShop and learn from GeoShop about various security issues. So what I'm going to do today is I'm going to show how we can take GeoShop, run security tests on it, and find interesting security issues that could happen to each one of us. And the first tool I'm going to start with is Zap. Zap is, again, another OWASP product. It's a tool that we can use for dynamic application security testing. And it's basically a proxy, like Fiddler or any other kind of proxy that you might already use. And because it's a proxy, it can inspect the request and response to our applications. This is why it's called dynamic analysis. It's look on the dynamic assets of our application, the things that our application produces at runtime. So it can look on the request and response and run various security rules on it. So the rules basically look on the request and response and say, hey, if you see this or you don't see this, raise an alert. And this is very valuable and can give us a lot of input. Now, the main problem with Zap is that you need to do a lot of manual work to give Zap all the information about your application. You need to basically load the browser, load your application in it, proxy the browser with Zap, and then start play with the application so Zap could proxy all the different parts of the application. This is boring and not something I want to do on a daily basis. But luckily, if we have good end-to-end test coverage, we can use them just for that. End-to-end tests usually, or behavior test, or acceptance test, or whatever you call it, are the kind of tests that try to mimic user operations with our application. And if we just proxy them through Zap, we will get a very good coverage of Zap on our application. So we can do it. This is a simple configuration of Protractor or WebDriver I/O, which is basic Selenium. And there is a small proxy setting here. And just by setting this small proxy configuration here, I tell the end-to-end test to proxy the request to Zap. And now I have good coverage of Zap of my application. And this also gives me another incentive to invest time in the end-to-end test, because now they have two purposes, quality and security. So the idea with Zap is basically run our end-to-end test, make sure they are proxy through Zap, and then just fail the build if Zap report anything. And here we can see an example from Circle CI. It's a bit hard to read, but luckily we also have HTML report, which is a bit easier to read. And I didn't put the full report here because there are a lot of information here. But the nice thing about Zap is that it tells us what the issue is and also give us tips about how we can fix it. So here, the issue that Zap report is CSRF. And instead of explaining what CSRF is, I want to show you a quick example of what CSRF. So let's see it. Hopefully it will work. OK, so this is GeoShop. You can see that it looks like a regular e-commerce site that you might worked with in the past. I think it's pretty, but not everyone agree with me. You can use it to buy things. For example, I can view it and I can buy it. And what I'm going to do today is I'm going to update my profile information. So let's set my username to awesomeYGLF, just for the fun. And that's work, and you can see that my username changed there. Now, let's say that a friend emailed me a web page of funny cats. This is the web page. It shows a really funny GIF of cat riding on a Roomba. And I think I want to like it. Who here think it's a good idea to press the like button? Damn. OK, you all passed. If you're looking for a job, we are looking for awareness software developer, so come talk with me later. Anyway, I want to press the like button, and thank you, Elad. So let's press it and see what will happen. And for some reason, just by clicking the like button, I was redirecting to GeoShop, and my username was changed. And if I go to this instance of GeoShop, I can see that it's persisted. It's not in that session. And some magic happened here, right? I click on a button in a totally different website, ilikecats.com, for example, and somehow my username on GeoShop was changed. And this is pretty serious, and if that's not scary you, I imagine it was a form that allows you to pass money or change your password or anything like that. And now imagine that totally random website on the internet could trigger this form. Now it's become a bit more scary. And if you think this don't happen in production, I think it was a month ago that WordPress has a very similar issue that led to hackers running code on WordPress. So it happens in production, and it's not for demo purposes. So let's talk about what happened here. So this was CSRF, or cross-site request forgery. Cross-site request forgery is the issue we have when we have a very special kind of HTTP request. So let's look on the original HTTP request. This is the request that was done by JuiceShop, the normal request. You can see that there is the body down there. It's a regular form post with the username. And this is the interesting part. The authentication to JuiceShop is done using a cookie. Cookie is something you can use in the browser to persist user state or for authentication. And it's basically a special header that the server sends, and the browser automatically sends with any request sent to JuiceShop, localhost 3000, for example. This is very good when we write the code. But what happens if someone produces a malicious website? And this is the code I wrote. It's an amazing HTML website. I'm very proud of it. So what will happen here is we have the iframe showing the GIF, and we have a form. And the interesting part about the form is that it posts to JuiceShop, localhost 3000. And because of the cookies mechanism, the browser will automatically add the cookie to this form post. And if I had an hidden value, hidden input with the value evil for the field username, when I click the me like, the form will be submitted, and my username will be changed, and all happened just because I use a cookie authentication that is automatically added. And again, this is a mistake I could do, and I'm sure all of us could do, just because we are not aware enough of CSRF. This is a really simple HTML form, and you can see a lot of examples of this is how we should write HTML form, and this is how we should do authentication. And just because the developer here weren't aware of CSRF, they had a really serious security issue. And this is something we could find just by running Zap, who reported it for us and allow us to fix it before it gets to production. So how we can fix CSRF? There are two ways. First is by using a special cookie attribute called SameSite. It's pretty new. I think it's 2 years out or something like that. It's basically tell the browser, send the cookie only if it's from the same site, like the name implied. The second is a bit more complex. It's called anti-CSRF token, and it's a random value you add to the form, which basically provide others from generating static sites. It's a bit complex to explain. I don't want to go into that, but you have all the details down there. It's a link from OWASP explaining how to fix CSRF. So this was DAST, or Dynamic Application Static Analysis. I mixed up the acronym. And it's really nice, but it's look only on the request and responses. It doesn't look on the code itself. And because it doesn't look on the code, we can't really know where the issue is. Right? You saw with Zap, Zap can only tell us you have an issue on the profile page, but not where the issue comes from, on which line of code. And this is why we might want to use static analysis, which is basically automated code review. It's a tool called Node.js Scan. And this tool basically read your code and look for security issues. Running it is relatively simple. We can run the CLI, tell us which folder we want to scan, in this case the folder with all the routes, and then we can tell it I want a report file so I can fail the build. So now I have a report file from Node.js Scan in JSON format with all the findings in my code. The problem is my CI don't know what to do with JSON files, right? It can't really say, the CI usually don't know how to read the report file and fail the build. And more importantly, security tools can produce false positive. It's expected. It's really hard to have security tools so don't have false positive. And we want a way not only to fail the build if there is something in the JSON, but also ignore false positive. And here we can use another tool from us called called Glue. I'm one of the leaders, and I have stickers of Glue, so come talk with me later if you want some stickers. Glue is basically the magic that take this report and fail the build if there is anything on the report. And we can just run Glue. We give Glue the report from Node.js scan. And this is a Glue configuration file where we can basically tell to Glue, if you see this finding, just ignore it. I don't care about it. And this is the result. And now we have the build failing with the output from Node.js scan. And we can start looking on the issue. So this time we have no SQL injection, which is pretty similar to SQL injection, just instead of injection on SQL database, it's injection on NoSQL database, like Mongo or Redis. And this is an issue where a hacker can run arbitrary queries on your database, and it's as bad as it sounds. And we can see that it's on a file called trackorder.js. This is what's nice about static analysis. It tells you where exactly in the code the issue is. So this is the code. And this is the relevant part. This is the query to the database. It's basically looking the database for the order with the specific ID provided by the user. So if, for example, the user sent this ID, we will look for the order ID 1. What will happen with this input? And if you ever saw talk about SQL injection, you're probably familiar with it. We will get this input, order ID equal empty string, or 1 equal 1. Which will true for all the items in the database. And if you put this in JuiceShop, you will get all the items in the database, like expected. And it's include orders I didn't invite. And again, it's a really simple mistake. As a developer, I just want to write a query, get the items from the database, and I might not aware enough of SQL injection, so the tool saved us again. Mitigating NoSQL injection is relatively simple. First is very important, and if you take something from this talk, remember this line: never, ever, ever, under any circumstances, trust user input. If you get something from the user, be suspicious. This is really important. If you just remember this, you will write a lot more secure code than before. So here we have a user input, and we need to be suspicious. And to handle it securely, we need to sanitize it. Sanitize it means to remove any characters that might be malicious. So for example, if it should be ID, I should get only numbers and not letters or anything else. And this is how we can mitigate NoSQL injection. So we talked about scanning our code, and we talked about scanning the dynamic access our application possesses. But we forgot something very, very important, which is package scanning with a tool called Snyk. And why we need to scan the packages, right? We scan our code. Why should I care about packages? I'm sure you already saw this meme or something equivalent to this meme. And if you're familiar with NPM, you probably know that the result of using NPM is that most of the code in your application is not the code you write. You have a lot of code coming from random NPM models that you download from the internet, and you just trust them. So if you're scanning only your code, you miss a huge part of the code running in your application. And now imagine that one of these packages contains security issues. The main problem is that the packages are usually open source. So I, as a hacker, can go read the code of the package online on GitHub and say, hey, there is a security issue there. And now I know about a security issue in your application, and you don't know about this. And this is really, really bad, because they can use it to exploit your application. To mitigate it, we can use Snyk, and it's really easy to use Snyk. It's a lot easier than the previous tools I showed. You don't need to have a CI, you just need to sign up on their site. It's a commercial product, but they have a free tier, so you can start using it. And after adding your project from GitHub, for example, they will scan it and show you the status of your application. So for example, you can see that I have 2 manifest files. They both package JSON, and the number of issues I have on each one of them. And what's more interesting about Snyk is they also watch you in the future. So for example, if now I'm using Express version 2, and it's not vulnerable, but tomorrow someone will report a security issue to this model, Snyk will tell me, because they keep watching my dependencies. So let's look on one of the reports here and understand what the issue is and see if we can exploit it. So this is the issue with Snyk, and we have XSS here, or cross-site scripting. XSS is a very, very nice attack where hackers can run arbitrary JavaScript on your application. And we all know what you can do with JavaScript, so now imagine you can run JavaScript on your bank website. It's really nice. And now imagine that you can persist this JavaScript, so anytime a user can view the bank page or something like that, your JavaScript code is running. It's really, really bad. And this is why hackers really like to have XSS. And this is the most naive XSS attack. I'm basically sending the web page a simple script trying to display an alert. It usually don't work because this is usually blocked, but this is just an example. So let's go back to the issue. And the issue is with a package called Sanitize. So we have here a really good developer who say, I want to mitigate XSS, so I will sanitize the input, right? So they added a package, Sanitize, to sanitize the input. But this package has XSS. And what happens if you try mitigate XSS and this package has XSS? You have XSS. It's really nice. And again, because everything is public on GitHub, we can go to the original library on GitHub and view the original issue. So this is someone reporting the issue on Sanitize HTML. And now, because we are smart hackers, we can read the issue, understand, I can run this on JuiceShop and do the exact same thing and exploit it. So this is an example. It's a variation of what showed on the issue on GitHub, just that it will work on JuiceShop. And what I'm doing here is I'm left in a comment. And the content of the comment will be displayed on another page. So if I'm right, this part, the JavaScript alert XSS, will work. And indeed, if we view here, we can see the XSS. And again, it all happened because a very, very simple mistake, just using package, something that seemed normal but could be really bad for our application. Fixing it is very simple. Snyk has a nice fix button for you. Snyk has a really nice button for you. So just by clicking on the button on Snyk, you can tell to Snyk, hey, please open a fix PR for me. And Snyk will create a PR with the fix. In this case, they will update the version. And all you need to do is run your test and merge the PR, and you're done. There is no more risk from this package. So this is really awesome. OK, so let's talk quickly about how we can mitigate XSS, because it's a really serious risk, so it's important to think about what we can do about it. So mitigating XSS. Again, the most important rule here is never, ever, ever trust user input. This is another example of malicious user input. And just because we trust it, we can have security issue. And again, like SQL injection, sanitization, there are also very good security headers. Headers that just by, if your server just returns these headers, you will not have XSS, or the damage will be a lot, far less bad. And I have a link on the slide for OWASP cheat sheet, teaching you how to mitigate XSS. And finally, if you're using a framework like React or Vue or Angular, you might be thinking that you should not care about XSS because the framework handled it for you. The sad news, this is not actually true, and you can have XSS if you're using a framework like React or Angular. And I have a link on the slides teaching you why you have XSS issues on Angular. Wrapping up. So we started by looking on the PR from JuiceShop and showing the various security issues. And I talk about 3 types of tools, Snyk, Node.js, Scan, and Zap. You have the summary on the slide, so look on them later. Showing each one of the tools and how easy to integrate them. Snyk is the easiest. Node.js Scan is a bit harder because you need to have a CI. And Zap is the hardest one because you need to start proxy your end-to-end test and all that, and it's a bit more complex. I also have a link on the slide for a blog post I write, and the blog post pretty much go through all the things I talk about today. So you have all the information there, and you can use it. And just before I finish the talk, I want to ask you for feedback. So if you have anything to share about the talk, how I can make it better, feel free to come and talk with me later. I will be here all day. I'll be happy to hear it. I started by talking how your code is now the security of the organization you work for. And now it's your move. Now you know what you can do to build a more secure application. Choose one tool and start using it on your application. Thank you very much. I was Omer, and you have everything on my Twitter account. And of course, we hire, so come talk with me later if you're looking for a job.